I'm going to talk about eccentricity in terms of ellipses, since none of the other videos that I did on ellipses talk about eccentricity. Oh, I can't spell eccentricity either. There should be a C there. And eccentricity is going to be a value that describes the shape of an ellipse. Now, we know that ellipses can be kind of circular. They can start to flatten and elongate. They can be really elongated. And the eccentricity is going to be described by a value between 0 and 1, where the closer to 0 you are, the more the ellipse looks like a circle. The closer to 1 you are, the more elongated or eccentric the ellipse is. And E, the eccentricity, is going to be described by the value C over A, where we know C is the distance from the center to a vertex, not a vertex, to a focus, and A is half the length of the major axis. So let's do a problem where we're given eccentricity and figure out what we're going to do with it. Write an equation of an ellipse whose foci are at 3, 5, and 1, 5, and has eccentricity 0.25. First thing I'm going to do is I'm going to change that back into a fraction, because when we're talking about C over A, it's easier to tell C is 1 and A is 4. Next, I like to draw a picture, so I have kind of a clue as to what's going on when I'm doing this problem, because right now I don't know how this ellipse is elongated. So I'm going to graph the foci. So one of the foci is at 3, 5. And one of the foci is at 1, 5. So I now know that the ellipse is elongated like this. So I know I'm going to use x minus h squared over a squared plus y minus k squared over b squared equals 1. Next, where's the center of this ellipse? Well, the nice thing about the foci is the center is the midpoint. So if I find the midpoint of the foci, I'll know where the center is. Remember the midpoint. Add the x's, divide by 2. Add the y's, divide by 2. And I'm going to find out that the midpoint is at 2, 5. That's my h and k. Next, I need to know what a and b are in order to finish this equation. Well, I know what a is. A is 4, so a squared is going to be 16. But I don't know what b is yet. Well, the nice thing is I have this little equation that I can use to find a missing term if I don't know what it is. C squared is equal to a squared minus b squared. So c squared is going to be 1. A squared is going to be 16. I subtract 16, and then I get rid of the negatives, and I find out b squared is 15. So I find out the equation of this ellipse is x minus 2 squared over 16 plus y minus 5 squared over 15 equals 1. And I use the eccentricity to tell me what C and A were. I used that information to find B. And then I plugged a squared, b squared, and the center into the equation of the ellipse. Let's look at one more problem. Write the equation of an ellipse, which has a vertical major axis of 20 units. Its center is at 3, 0, and E is equal to 7 over 10. Well, first of all, if it has a vertical major axis and the center is at 3, 0, the ellipse must look like this. So I know H, I know K, and I know I'm going to use the equation y minus k squared over a squared plus x minus, let's make sure that looks like a minus, x minus h squared over b squared equals 1. So I know h and k. If I know the eccentricity, I know c over a. So I know a is 10, so a squared is 100. Now, what I don't know yet is b. Well, let's use c squared is equal to a squared minus b squared. C is 7, so c squared is 49. A is 10, so a squared is 100. I'm going to subtract and then get rid of the negatives, and I find out b squared is 51. I don't even have to take the square root of it to plug it into the formula. So the equation of this ellipse is y minus 0 squared over 49 plus x minus 3 squared over 51 equals 1. And that's how we use the eccentricity to help us find the equation of an ellipse.